Aucubin is an iridoid glycoside. Iridoids are commonly found in plants and function as defensive compounds. Iridoids decrease the growth rates of many generalist herbivores. Natural occurrences. Aucubin, as other iridoids, is found in asteroids such as Aucuba japonica, Cornaceae, Euchemia ulmoides, Euchemiaceae, Plantago asiatic, Plantago major, Plantago lanceolata, Plantagenaceae, Gallium apurine, Rubiaceae, and others. These plants are used in traditional Chinese and folk medicine. Agnoside is composed of aucubin and p-hydroxybenzoic acid. Health effects. Aucubin was found to protect against liver damage induced by carbon tetrachloride or alpha-amanitin in mice and rats when 80 mg per kilogram was dosed intraperitoneally. Chemistry. Aucubin is a monoterpenoid-based compound. Aucubin, like all iridoids, has a cyclopentane, C, paran skeleton. Iridoids can consist of 10, 9, or rarely 8 carbons, in which C11 is more frequently missing than C10. Aucubin has 10 carbons with the C11 carbon missing. The stereochemical configurations at C5 and C9 lead to cis-fused rings, which are common to all iridoids containing carbosyl glycoside in non-rearranged form. Oxidative cleavage at C7, C8 bond affords sequiridoids. The last steps in the biosynthesis of iridoids usually consist of O-glycosylation and O-alkylation. Aucubin, a glycoside iridoid, has an O-linked glucose moiety. Biosynthesis. Geranyl pyrophosphate, GPP, is the precursor for iridoids. Geranyl phosphate is generated through the mevalonate pathway or the methylerythritol phosphate pathway. The initial steps of the pathway involve the fusion of 3 molecules of acetyl-CoA to produce the C6 compound 3-hydroxy-3-methyl-glutaryl-CoA, HMG-CoA. HMG-CoA is then reduced in 2 steps by the enzyme HMG-CoA reductase. The resulting mevalonate is then sequentially phosphorylated by 2 separate kinases, mevalonate kinase and phosphomevalonate kinase, to form 5-pyrophosphormevalonate. Phosphomevalonate decarboxylase through a concerted decarboxylation reaction affords isopentenyl pyrophosphate, IPP. IPP is the basic C5 building block that is added to prenyl phosphate co-substrates to form longer chains. IPP is isomerized to the allylic ester dimethylallyl pyrophosphate, DMAPP, by IPP isomerase, through a multi-step process, including the dephosphorylation DMAPP. IPP and DMAPP are combined to form the C10 compound geranyl pyrophosphate, GPP. Geranyl pyrophosphate is a major branch point for terpenoid synthesis. Current biosynthesis studies suggest that the most probable synthetic sequence from 10-hydroxygeranyl to ATP-iotrieal is the following. Dephosphorylation of GPP leads to a geranyl cation that is then hydroxylated to form 10-hydroxygeraniol. 10-hydroxylgeraniol is isomerized to 10-hydroxynerol. 10-hydroxynerol is oxidized using NAD to form a trialdehyde. Finally, the trialdehyde undergoes a double Michael addition to yield ATP-iridotriol. ATP-iridotriol is another branch point intermediate. The cycloazatin in reaction to form the iridoid paran ring may result from one of 2 routes. Route 1, a hydride nucleophilic attack on C1 will lead to 1O-carbonyl atom attack on C3, yielding the lactone ring. Route 2, loss of proton from carbon 4 leads to the formation of a double bond C3-C4. Consequently, the 3O-carbonyl atom will attach to C1. Based on deuterium tracking studies, the biosynthetic pathway for orbitine from the cyclized lactone intermediate is organism-specific. In Gardenia jasminoids, The cyclized lactone intermediate is glycosylated to form bosnioloside that is then hydroxylated. On C10, bosnioloside is oxidized to geniposidic acid. Geniposidic acid is then decarboxylated to form bartesioside. Bartesioside is then hydroxylated to form Aucubin. The Scrophularia umbrosa biosynthetic pathway is different from Gardenia jasminoids. In Scrophularia umbrosa, the lactone intermediate is glycosylated and oxidized at the C11 carbonyl to form ATP-idexoylogenic acid, which is then converted to deoxygen-iposidic acid. Deoxygen-iposidic acid is hydroxylated at C10 to geniposidic acid. Decarboxylation and hydroxylation of C6 leads to aubergine.